Hi, and welcome to Always Eclectic Stacy. This is 5-minute chemistry where you learn chemistry concepts and see examples in 5 minutes or less. This is the Ionic compound series where we're taking the name of an ionic compound and taking it to a balanced compound. And today we're working with iron 3 sulfate. Ready, set, let's balance. Today we're balancing iron 3 sulfate into a balanced compound, and again I'm going to show you 3 different ways of doing it. The most important thing though is to remember that you do not have to understand perfectly all 3 ways. One of the ways will work best with your brain, and you should really embrace that way. I'm just showing you all 3 so that you really understand how it works. The first step in any of the ways is to identify your cation and your anion, and go ahead and write that ion down. Now remember, the cation is positive because cats have paws, meow, 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 and it is always written first in an ionic compound. Iron, therefore, is our cation, and we know that iron is a transition metal, and that 3 in Roman numerals next to it tells us the charge, because you always have to be given the charge or a way to find a charge in a cation of a transition metal. Then sulfate is a polyatomic, which means it does have an oxygen or it's a compound, and that's our anion or polyatomic anion today. And if you're not sure about those, go ahead and check out our video that does have the polyatomic anions in them, and refresh yourself. And sulfate is written as SO₄². So the first method that we're going to show you is the crisscross. And this is the one that I would experience most people really enjoy. I have a hard time with it because you always have to remember that last step of reducing, but I'll show it to you. So you have Fe3+, and you're adding SO₄². And for this one, the superscript, remember the ones that fly high like Superman, of the one of one becomes the subscript of the other. So this 2 on sulfate becomes the subscript of iron, and this 3 on iron becomes the subscript of sulfate. So we can write it. It becomes Fe3. And then we need more than one of this compound, and SO4 is considered one element or one compound, so we have to put it in parentheses because we want more than one of this whole compound. If you start distributing the 3 like a lot of people do because that's the math way, you're not going to keep the same compound. So it's SO4 and then 3 on the outside, saying 3 of this entire compound. Sorry, I meant to write 2. Oh, I messed up here. This is supposed to be a 2, guys. Sorry. And this is supposed to be a 3. I apologize. I was so focused on the crisscross and the next step that I forgot to write the right subscripts down. And then you ask yourself, do I have to reduce? Can I make this 3 and this 2 any smaller? And the answer is no, so you leave it alone. The next method is the LCM method, and this is my favorite method because it really breaks it down. It automatically reduces, and you can really be deliberate about your parentheses, and I'll show you what I mean in a second. So remember with LCM, we're going to make the equation. So we're going to put the Fe out here, and we're going to put the SO4 here. And then in that first column, I always think of it as a column or first part of the equation, you're going to put the charge number, not whether it's a positive or a negative, because that'll work itself out. So we have a 3, because the charge of iron is 3, so the charge number is 3. And we have a 2 for SO4, because the charge is 2-. So we're just taking the numbers, not the positives or the negatives, And we're going to go ahead and make an equation out of it. 3 times something, and this something becomes the subscript, equals your LCM. And 2 times something, and that something will become your subscript, becomes your LCM. And remember, it has to be the smallest whole number that both of them will go into as a whole number, because we really don't deal with halves of subscripts or halves of a compound. So between 3 and 2, the smallest whole number that they can each go into is actually 6. So then we ask ourselves, what number, which becomes our subscripts, makes this equation true? So 3 times something equals 6, and that's a 2. And 2 times something equals 6, and that's a 3. And that becomes our subscripts. So for this one, we don't even have to worry about whether or not there's parentheses, there's no subscripts. It's an independent element, so we can go ahead and just write Fe2. Now with SO4, when you see a compound out here, it should ring alarm bells in your head like, hey, this is a compound. If I need more than one of them, I need parentheses. So you're going to go ahead and put this in parentheses because you do need more than one of them. In fact, you need 3 of them. And therefore, you need 3 SO4s. Please do not distribute. And so these two are the same, but whether you crisscross or you do the LCM, you're going to get the same. And our last method is the equation method. This is my almost least favorite way of teaching this because it is the most tricky, but if you've already learned equations, it will make sense. But we haven't learned equations yet, at least in my class. So we have Fe3 plus, and we're adding that to SO4 minus. And we're going to balance it, thinking that we need a 0 charge on the balanced equation. There should be no charge on the balanced equation. So how many 3's equal a 2 and how many 2's equal a 3? Well, this is where it gets tricky. They don't equal, so you need to add more. So we can add another 3 charge, which was going to make a 6 charge. And then you have to add how many 2 charges will make a 6 charge, because remember, whole numbers are easier. Now we have 1, 2, 3 SO4s. So we can write that over here. And now we have 1, 2, 3 charges, which will equal a 6. So now we have Fe3. And these 1, 2 go out here. So it becomes 2 Fe3 plus 3 SO4 will equal this. And this is how you balance with the equation method. It takes a little more thinking time. If you've learned about balancing equations, this might make more sense to you, but you have to really think about the numbers, whereas these are setting up either a crisscross or an equation, which might help your mind more. Thank you so much for watching Always Eclectic Stacy. I know we went slightly over the 5-minute mark, but I did show you 3 different ways of balancing iron 3 silicate, and this is an important step in understanding ionic compounds. If you do like my videos, please do not forget to like and subscribe, and check out some of my other content. Thank you so much. Have a great day.